Hello my friends and welcome to this new practical activity on, this time, support vector regression. So, I have to start by telling you that the model we're about to implement will be slightly more advanced than the models we built before. But it's totally fine, we will do it together and we will succeed 100%. So, why is it slightly more advanced? Well, that's because we will have to play a lot with feature scaling, and I can tell you that after this implementation of the SVR model, you will be a master in feature scaling because you will know not only how to apply the feature scaling transformation, but also how to apply the inverse transformation, to go back to the original scaling. So you will know all the sub-tools, let's say, of feature scaling, and you will handle them like a pro. All right? So if you're ready, let's start. And just before we go inside the folder, let's make sure here that we're all on the same page. I gave you the link to this folder, containing all the codes and datasets right before this tutorial and an article, so make sure to connect to it. And now we should all be on the same page, and therefore we're going to go, of course, to part 2 regression, and then, of course, to support vector regression SVR. All right, and as usual, we're going to start with Python, so we're going to go to that Python folder, inside which you will find the same dataset as before, because I would like to compare the performance of different regression models on this dataset, which proved to have some nonlinear relationships, between the feature, which is the level, the position level going from 1 to 10, and the salary going from $45,000 to $1 million per year. So here again, this is exactly the same scenario. We want to train this time a support vector regression model to learn and understand the correlations between these position levels and these salaries. And to quickly remind the context, we are hiring a new person who is expecting a 160K salary, justifying this by the fact that this person earned a 160K salary in the previous company. This data is exactly the data of the previous company, with the different position levels from business analyst to CEO and their corresponding salary. And so not only we want to train a model to learn these relationships, but also we want to deploy this model to predict the salary that this person had in this previous company, knowing that indeed this person was a region manager for a couple of years and therefore is considered to have a position level of 6.5. So that's the exact same scenario, exact same dataset. And so now let's build the support vector regression model on this dataset to see if it performs better than the previous model, which showed great results, the polynomial regression model. All right, so let's do this. Let's close this and let's open our support vector regression implementation, either with Google Collaboratory, if you love it, or with Jupyter Notebook, because indeed it is an IPYNB file. All right, so that's the whole implementation. Let me quickly show you the structure of the implementation. We're going to start by importing the libraries as usual, then importing the dataset, then applying feature scaling. So this is interesting. This time we have to apply feature scaling because in the SVR model there is not this, explicit equation of the dependent variable with respect to the features, and mostly they're not those, coefficients multiplying each of the features and therefore not compensating with lower values for the features taking high values. No, this time the support vector regression model has an implicit equation of, the dependent variable with respect to the features, so we don't have such coefficients and we will definitely have to apply feature scaling for this model. So you see, you start to understand when and when not to apply feature scaling. Well, we don't have to apply feature scaling for linear regression models where you have indeed those coefficients that can compensate with the high values of the features. And so, of course, these include simple linear regression, multiple linear regression, and polynomial regression. And you will see later on in the course many other models. And for other models which usually have an implicit equation, an implicit relationship between the dependent variable y and the features x, well, usually for these models we have to apply feature scaling. All right? Then we will, of course, train the SVR model on the whole dataset. This time it's the same. We won't split the whole dataset into a training set and a test set because we want to leverage the maximum data to learn these correlations between those position levels and the salaries. So we won't do that split, and we will directly train the SVR model on the whole dataset. Then after this training, well, we'll have a smart SVR model, which therefore we're going to use to predict this new result and exactly that salary of this position level of 6.5. And we will compare, of course, that prediction with the prediction of the polynomial regression model, which I've kept here. And then, of course, we will visualize the SVR result in low resolution and high resolution to see, of course, the regression curve of the SVR model. All right, I'm sure you noticed that I did not click on each of these contents. Well, I did that on purpose. It's because I don't want to reveal the prediction, the predicted salary by the SVR model. I want us to save the surprise until, we execute that cell to return that predicted salary. All right, let's keep the suspense. And now, whenever you're ready, let's create a copy of this file, because this one is in read-only mode, and therefore we want to create a copy in order to re-implement it from scratch together. And make sure to focus, because this will be quite more advanced than before. So let's put that right here, and there we go. Now let's remove the cells and let's try not to look at the final result, right? You just put your eyes around here, you don't look at the results, because let's try to keep the surprise of the predicted salary up to the end, up to the final execution of the code. All right, so let's remove all this and this as well, only the code cells, right? Please keep all the text cells so that we can keep the well-highlighted structure of this implementation. All right, and now really make sure to not look at the result, the output of the code cell, because that's where you will see, the final results. All right, I managed to do it. I did not look at it, even if, of course, I know the result. But what I mean is that it was totally possible not to look at it. All right, so that's the whole structure. Now we're ready to start this implementation. And so there you go. I suggest that we really tackle in a flashlight. I love saying this, I know, but we will tackle in 1 second that data preprocessing phase, except that part, because that part is actually not that direct. There are going to be some things to explain. All right, so let's do this. Let's start by importing the libraries. And of course, to do this, we're going to use our data preprocessing template. I hope you have it prepared. So there you go. Let's first get this code to import the libraries in a new code cell. Paste here. Then we're going to import the dataset. And actually, to do this, we'll get our polynomial regression implementation, because this is the exact same dataset, and we don't have to explain that again, because you perfectly know and understand now how this works, right? And voila, that's the thing I wanted to do in 1 second. Now we're going to quickly upload the dataset in order to execute this cell after this one, of course. So now it's connecting to runtime to enable file browsing. And in a second, we should be able to see the upload button. Perfect. So upload. And then, as usual, we're going to go into our machine learning A to Z folder. I like to put it on my desktop, but find it wherever you put it on your computer. Then part 2 regression, then support vector regression, then Python. And there you go. That's the dataset. Open, and it will be uploaded inside the notebook. Perfect. All right, then we're going to execute these 2 cells and this one as well. All right, and perfect. Now we have the dataset. And now we're going to stop here for this tutorial, and we will tackle this next step, feature scaling, in the next one. And make sure to be prepared and ready to tackle this, because we'll have a few things to do. It's not difficult, but just make sure to be focused for that next tutorial, because I'm going to explain a new situation where you have to apply feature scaling in a certain way. So I'll see you in the next tutorial, and until then, enjoy machine learning.